Hello, guys.
Hey, how's it
Hello.
going?
Good, good. So, how is the Halloween?
Very spooky.
You're joking.
Honestly,
My wife made cheesecake.
Oh, cool. Seems like Black want to say something, right?
I said it was spooky.
Okay. So, how about the girls in our class? Does anybody want to share the Halloween? Okay. Anybody want to share the Halloween? Okay, so let me share my Halloween, if you don't mind. So previously, I was living in the rented apartment buildings. They always have a security gate. And I've been in America for many years. However, there's no kids ever knock on our door asking for candies. But this year, I moved to my friend's house. This is my friend's house. And he's living a middle class neighborhood. And I'm very surprised. So many kids at the Halloween nights, they come to ask for candies. Yeah, just surprised to me that so many kids come here asking for candies.
At the
We were
apartment?
house. This is a
Oh,
house.
okay. Okay.
Okay. So we were watching a horror movie together. However, we are not merging into the horror feeling because every time we watch for 5 minutes, somebody knock on the door. Treat or trick, treat or trick. We don't have the horror feeling while watching the horror movie because kids are always disturbing us. Yeah, that's my sharing.
Nothing like pestilent children to ruin Halloween.
Okay, so let's begin the class. So today we're learning the section 6b. But before we learn section 6b, last time we had one small question at the end of the previous lecture. So let me switch to my document camera. So this is from the last lecture slides. And we learned 3 measures to discuss about the central of the data or the average of the data. There's 3 ways. We have the mean, median, and mode. So each of them have different property. And by same property, I mean different advantages. So you should pay attention to this last column. The mean is most easily understand, can be most easily understood. The median is applied when we have outliers. The mode, when you have the qualitative, such as those discrete numbers on the genes. Okay, so genes, the size always has like a discrete characters, values, right? Okay, so we have the next question, example 6. Ask us 3 scenarios. And each scenario, we should pick up a best measure of its average or the center of the distribution. And you guys have saw my answers here. I just want to briefly explain why I think those are the correct answer. Feel free to ask me any question. Feel free to discuss with me. So Dennis Low in Omaha in January. So by the way, Omaha is where Warren Buffett lived. He is one of the richest person on this planet, Omaha. So I would recommend use mean because look at the description. it is most commonly understand. Does it have outliers? Using my common sense, I do not see any outliers there. So there's no outlier, and SLU4 is not qualitative. It's not qualitative. So I rule out the two possibilities. So I do not see any reason why not use A, the first choice. Okay. So I just read the sentence here and match the description here, and I rule out the two of them. And I see no reason for me to not use me, and I pick up me. So anybody has any questions, suggestions? So that's my explanation for why using me here. Part B, per capita earnings in New York City. So the keyword here is New York City, NYC. So I think many of you have been to New York City. I've been to there also. So one observation I have about New York City is that this city has some extremely rich people and extremely poor people. Very rich people, very poor people. So many CEOs are there, many movie stars are there. They are super rich. And they also have a district, I think on the north side of the Manhattan Island, which is called Harlem. Harlem is very poor. Too many crimes there, Harlem. It's also in New York City. So by saying extremely poor people, extremely rich people, I mean there are too many outliers, too rich people, especially rich in terms of the richness. So when there are outliers, this fit into the situation of New York City very well. We do have quite a lot of outliers. So I read the description here. I found that the median income is most appropriate for the per capita earnings in New York City. Okay. So any question on this? Any opinions? Okay. So then comes the C, waist size of men's navy jeans. You can see my answer is mode. Again, why do I pick mode? I read the descriptions here. When I read this one, I see most appropriate for qualitative data. By saying qualitative, I mean some discrete sizes are also qualitative, right? So navy makes jeans, they do not make all continuous size. They're discrete, they increase every inch, maybe 2 inches, I don't know exactly, but they increase certain amount of unit, right? Every time they increase for the size of the jeans. So I would say mode is very appropriate for this situation because it is qualitative data. Okay, so that's my explanation for the last unsolved problem in the previous lecture. Does anyone has any question, any opinions? Okay, let's continue. So actually, I feel like we have done the hard part of this semester already. So all the leftover materials kind of, I would say it's not easy, but as long as you understand the language, then you get the question. So 6P is about measures of variation. Remember my word, you have to understand the language. The range of the dataset is just the difference between the highest and the lowest. That's it. It's just the highest, we also call it max. lowest, we also call it mean. So it's just such a simple formula. Biggest minus the smallest. That's it. So we learned those mean, median, mode last class already. So this time we also add a new concept, range. However, everything can be done very easily, right? So this is a very simple formula. So instead of me doing the calculation for you, I would like to give you, let's say, 3 minutes working on this one. Not right now. So let's finish reading all the definitions. So I'll give more time for this question and the next question you have. So let's continue. See, the next definition is the 5-number summary. Those are the 4 most important 5 numbers to summarize the data you have. Again, do not stress if you cannot remember any of it. Just a bunch of terms here, okay? In your eyes, just a bunch of terms. Don't worry. So let me explain each one. Lowest value is just smallest value, right? This is most easily understood. Lower quantile, we will see the definitions given here. Median, we learned already. Up quantile, the definition is also given below. Highest value is just biggest value, okay? So we just need to focus on those 2 new terms. Okay, so the first new term, lower quantile, or we also call the first quantile, divides the lowest force of the data from the up 3 force. So this is just a description, not a definition yet. The real definition is here. The median of data values in the lower half of data. This is the definition, okay? Please underline this sentence in your lecture notes. So we know the word median already. So we just need to figure out what is the lower half. And this is very intuitive. There's no technology at all. So just, if you have, let's say 10 numbers, the lowest 5 are lower half. However, sometimes you have the odd number of data. Maybe you have 11. So the lower half is just the lowest 5, since you excluded the middle value. So if you have 10, the lowest 5. If you have 11, still lowest 5, middle remote. Discard. Middle value discard as the lowest 5. Does anyone has any question definition about this definition? So I hope this is intuitive. So the median of a lower half, okay? So it's just a median, okay? A median, a special kind of median. Similarly, you have the up quantile. Again, ignore this description. Focus on the definition, just the median of the up half. So everything is just the same with the lower quantile, but this time you just take the up half. Everything is still the same. If you have 10 data points, you just take the highest 5. If you have 11, just take the highest 5. Discard the middle value. Okay. The mid quantile is just a meeting. This is a fancy way to say the meeting. So in your mind, mid quantile is just a meeting. There's nothing to say here at all. Okay. Anybody have any question on my explanation here? Okay, so now you see we have example 2. Previously, I said we are going to do example 1 for 3 minutes. For this example 2, I would also like to give you, let's say, 2 minutes. So together you have 5 minutes for example 1 and example 2. They're very similar. Do not overthink about it. So try on your scratch paper, then we'll come back together to write every detail out. Okay, 5 minutes for example 1 and example 2. Try on the scratch paper. Do not be lazy. Okay, 5 minutes is over. So let's see. For the mean, we just add all the numbers together. Divide by how many numbers you have in total. So what would it be the mean? Can anyone tell me? Anybody? Any brave men and women?
I got 43.43.
Thank you. So the median, you just pick up the middle number. You read it, 7 numbers, the middle is this one, right? Just 40. Mode, the number which repeats itself most often. So you see 35, repeated twice. All other numbers are unique. They're not repeating each other. Range, the biggest number minus the smallest number. 59 minus 29, just 30. That's it. So we are done with this. Does that sound easy? Any question? Then example 2. Low, just read it, lowest here. Max, just biggest number here. Median, just a middle number. So you have 9 numbers in total. So this guy is a middle number. Q1, the lower quantile. So when you have 9 numbers, so you should find the median of the lower half. This is the lower half. This is upper half. This is the lower half. So look at what is the median for this guy. You have 4 numbers. So the median is between 1 and 2, right? Between 1 and 2, just the central of 1 and 2. So it should be 1.5. Do you have any question? Why this is 1.5? So let me repeat this. When you have an even number of data, the median is just the central 2 values taking the average. 1 and 2 taking average, you have 1.5. Okay, any question? So Q3, the upper quantile. Okay, it's a median of the upper half. So should be the middle point between those 4 and 4. 4 is same with 4, so the middle point is just 4 itself. That's it. Does that sound easy to you guys? Okay, let me write this down in case somebody is shy and not willing to ask. So this is just this median of lower half, which is the average of those 2 central values. The median of upper half is 4 and 4. The average of those 2 middle values of the upper half, 4 and 4, so it goes back to 4. Okay. Okay, so let's look at how to draw a box plot. Box plot. Before we draw a box plot, let's watch a video, vivid video. Okay, you guys see my screen? This video is 2 minutes and 32 seconds. I think this video is funny. Let's begin.
That quest is so cool. When you watch it, you're no fool. That's what makes it cool. Hello, and welcome to StatQuest. StatQuest is brought to you by the friendly folks in the genetics department at the University of North Carolina at Chapel Hill. Today, we're going to be talking about box plots. Box plots are bad to the bone. Check them out. Sometimes box plots are called box and whisker plots. Here's the box, and here are the whiskers. The line in the middle of the box is the median value. 50% of the data is above the median. 50% of the data is below the median. Medians are useful because they're not as swayed by outliers as the typical mean or average is. George Carlin, host of the children's television show Shining Time Station, once said, "Think of how stupid the average person is and realize that half of them are stupider than that." I think Mr. Carlin was referring to the median, not the average, but that's okay. It's still funny. Within the box itself, we have 25% of the data above the median and 25% of the data below the median. So 50% of the data is within the box. Outliers are plotted as dots beyond the whiskers. Totes bad to the bone. It's common to overlay the original data onto the box plots. Now it's easy to see that this guy didn't get many measurements. And this guy got tons of measurements. This means we'll be more confident in the statistics calculated from this guy. Super totes bad to the bone. Bask in the awesomeness of box plots compared to the traditional bar plots. Both graphs show the exact same data. Hooray! We've made it to the end of another.
Okay, this is the end. So box plot, I hope what you get from the video is that box plot is just a way to express the median, the max, and the lower and upper quantile, those information in a simple graph. We have 4 steps when we drawing a box plot. Instead of me tutoring how to draw the picture, I just want to emphasize a few key points. Then I will leave example 3 as your own job in drawing the box plot. First, draw a number line spreads all the values in the dataset. What does this mean? It just means you have to, whenever you have an x, y coordinate, you should draw a number line from the max to the lowest. Okay. Second, include the value from lower to upper quantile. So let's say your lower quantile is here, your upper quantile is here. Include it, just draw a box here. Third, draw a vertical line through the box at the median. So here it says a vertical line. So I start drawing everything in this shape already. So this shape, all you can do is draw a horizontal line. So just where the center is. But if you are very strict following those steps, so you should have something like this. From lowest to highest, lower quantile, up quantile, then draw a vertical line at the median, shorter, not so long, not so long, not as long as those two ends. Then add a whisker. Whisker is horizontal lines with shorter vertical segments at the end. So my drawing is kind of failure. Actually, I should not make a solid line. And I should draw a dashed line, dotted line. It's connecting the lowest value and the highest value. So in your eyes, this should be dashed line. I'm sorry. I didn't draw it very nicely, but you get the idea, right? Anybody has any question? Okay. So I will leave this example 3 for you to do it. I give you, let's say, 4 minutes to do example 3. So you first need to calculate all the numbers here, then just use the numbers here to draw your box plot. I will share my screen. I share the example from the internet so that you can work as your reference. Okay, so I simply use Google to find the box plot examples. Open link, open. Here you go. Okay, so everybody should see my shared screen, right? So please use my shared screen to work as your reference while drawing for example 3. I'll give you 4 minutes. Right now it's 5:36. We'll come back at 5:40. Okay, please try it on your scratch paper. Do not hesitate to ask me any question. And if you feel comfortable around 5:40, I'll ask somebody to show their picture if you feel comfortable. Four minutes to work on it. Hello, people. I'm back. I see Elizabeth's question. It tells us to make histogram. Is it a box plot? I apologize. There's a typo here. So this should be a box plot. Okay. We're talking about how to draw a box plot. The exercise comes asking you to draw a histogram. So I hope that that's obvious. This is a typo. Okay, thank you, Elizabeth, for asking. So let's just draw it together. Law is very easy, just read it. Law is 1, max 7. Median, how many? 4. You have 11. So the median is this guy. Right? So the 6, so 3. Q1, lower half, just 2. Median of lower half is 2. Q3, the median of upper half is 4. Just read it and copy it. So let's draw a box plot. Let's just mimic what I found on the internet. We first find the low. Let's say the low is here. The max, let's say, is here. Low, max. Then you find the lower quantile, up quantile. So 2 and 4. I think it's somewhere here. So just draw a box. Oh. Oh, I forgot to draw a dashed line to connect the smallest and the highest. So let's draw it. Solid line here inside the box. Dashed line to connect to the max. Median, I believe, is here between 2 and 4. So just draw another vertical line. That's it. Success. Does anybody have any question? Okay, so I hope it's easy for you guys. So maybe some of you are shy, do not want to ask me questions. But when class is over, please just look at this graph, think about it. And I think I'm very confident you will figure it out. Okay, so it's everything is, do not overthink about anything. Everything is kind of basic. Since we had the box plot, now we really need to do something sophisticated. The one thing we need to do today is so-called a standard deviation. Definition is here. How standard deviation used to tell us how far on average any data point is from the mean. This is such a long, complex sentence. So I would just underline this part. How far on average any data point is from the mean. Okay, let's cover this word on average. How far any data point is from mean. Is this easy to understand? How far any data point is from mean? Just any data point from mean. Because we have so many data points, we need to take the mean of how far they are. We need to take the average of how far they are. this something is a little bit perplex, but please underline this sentence. After class, please read this again and again. The smaller the standard deviation, the closer the scores on average to the mean. What does this mean? The smaller this value is. But what is this value? This value measures how far those data points from the mean. So if they are not far, this number is small, it means they are not far. It means they are closer to the mean. Still, the word is kind of. Please read it after class. When standard deviation is large, or in other words, when they're very far from the mean, so the scores are more widely spread out. Does anybody has any question about the definition here? The definition something are not more complex. Once we do the calculation, you will see it's actually not that complex. So look at example 4. We have those test scores. We want to find the mean, and we are very confident. We know how to find the mean, it's very easy. We want to find the n, so which means how many data points we have. We just count 1, 2, 3, 4, 5, 6, 7. So this one is easy. And look, we have a table. The first column is x minus x bar. X is each of the data point. X bar is just a mean. X bar is a mean. So in other words, it's just the data point minus the mean. So which measures how far the data point is from the mean. Then we have the data value mean squared, which is this number here squared. Let's do, I'll do 1 or 2 entries for you, and you should be able to finish the rest of it. Just repeat my process. Once you figure out all the numbers here, you will be able to put the squares here. Then you should add all the numbers together. Now select step, add all the numbers together. This means adding everything together. Or the sum, everything. Once you add a number here, you divide by n minus 1. N is 7 already. So those numbers added divided by 7. Standard deviation, you need to take a square root of the variance. That's a lot of words. So let's do one. So what is the mean here? You have 99. Let's do together. Plus 33, plus 57, plus 75, plus 100, plus 81. Mean divided by 7, which get so let's work on the stuff together. I need to calculate how much the mean is. This is 180, 280, 370, 472, 547. If I add the numbers to correctly, I should get 547. Is that correct? Let me double check on the calculator. Yeah, I'm correct. Divide by 7. So I believe it is 78.14. Okay. I do 1, 2 for you. Then you just repeat all the process below. The mean, we got it, is 78.14. So what is the difference between the first data point and this guy? We just have the first data point, x 99 minus the mean 78.14. So you have 20.86. Then the mean data value means value minus mean squared is just this number squared. Which is, let me use my calculator. So I believe it is 435.14. How about the second value minus mean? Second number is 102 minus the mean 78.14. So you should have 23.86. So 23.86 squared is 569.30. So I did 2 for you guys already. I would like to give you 5 minutes to figure out the rest 5 and try to work on it on your scratch paper. Do not work on your lecture notes. Since you are working, when you're working on scratch paper, you can be very messy, write everything you want. However, you want a clear written lecture notes so that you can read in the future. Okay, so 5 minutes to finish calculating all the numbers and try to work on those numbers. Just follow each step by step. Feel free to ask me any question. Okay, so let's come back together to write the answers. So the third one is 33 minus 78.14, which give you negative 45.14. The third one is 57 minus 78.14, which gives you negative 21.14. What is the next one? 75 minus 78.14, which should give you negative 3.14. 100 minus 21.86. 81 minus 78.14 gives you 2.86. So we find all the differences, then we take a square. So I already did it on my computer since I know programming very well. So when I use my programming to do it, I just do it very quickly. And you can use your calculator if you are skillful enough. So you should be able to get very similar. I'm just copying what I did on my computer. This is 88. The next one should be 402. The next one, this guy squared, should be 9.88. The next one should be 477.73. Next one should be 8.16. This guy squared. Okay, then we need to sum up all the numbers on this squared side. So, by the way, are you guys interested what I'm doing on my computer? Let me just share my screen. I know you guys are curious. So I'm a stats measure. I use some software help me doing those numbers. And it's very quick using those software to do it. Do you guys see my screen?
Yes.
Okay, do you guys see those command lines I have here? The first line, I build a vector. Maybe you don't know what is a vector, but no worry. Just an array, a bunch of to record the test scores. The second line is I build another variable to record the difference. So those test score minus the mean. So every number minus the mean already. This is just plain English. So by the way, I'm just showing off why I can do it very fast on my computer using some statistical software. This is not a part of our lecture. This is not required for the homework or exam. I'm just showing there is some way you can do it very quickly. And I hope you guys can be statistical measures in the future. So let's continue. The next step, I just use the test score minus the mean. So let's first, you see this command line means I input this into a computer, control int. So the computer finished calculation of this line. So let's see what is A. I type A and press enter. Automatically, those numbers are given. I just copy the difference. Then the next line is A squared. I type A squared, control enter. So all the squared is automatically calculated. The next line is sum. I need to add all the numbers here we have. What do we have here? So let's Control Enter. So once I input that one, I see we have 3984.9. So that's not enough. Just the sum is not enough. We need the sum divided by n minus 1. N is 6. So divided by 6, 666. And we also need to take a square root of that guy. So I just, square root is just choose a ½ power. So taking a square root of that guy, you just get 25.77. So let's copy all the numbers we have. Just copy. The sum of all the squared, 3984.86. Variance divided by 6. We have 664.14. I just keep it. I'm lazy. I just keep 2 decimals. I think that's accurate enough. Then I take a square root. I get 25.77. That's it for this question. Oops. Somebody should remind me I'm running out of space here. But you can do whatever I do on my computer exactly on your calculator. It just take a little bit more work. Okay, so anybody has any question on those numbers? Let's continue to the next page. So here we have a summary of what we did in the previous page. Previous page, we follow each step. And we literally repeat everything here, taking divided by the array, taking a square root, everything here. So we just follow those steps here. So there's nothing new here. This is just a detailed explanation of what we did there. Let's look at example 5. Example 5. Again, we are required to do the standard deviation using technology. By technology, I mean any kind of number, calculator, computer would help. So we have a bunch of numbers here. And I'll post a YouTube video. If you have any kind of TI calculator, I'll put a YouTube video on how to use a TI calculator to find the standard mean, a standard deviation. I'm not repeating every process we just did before. I just keep a note here. Standard deviation. SD means standard deviation. So if you don't have a TI calculator, Please watch the video on how I did it on the previous page. Okay, so almost exactly the same process. We're not going to repeat that. So we'll skip this question. Let's go to the next section. Range rule of the sum. The standard deviation is related, but only approximately related to range of distribution by the range rule of sum. We have this approximation. The standard deviation is only a quarter of the range. If we know the range of data set, remember that the range is just the difference between the highest and the lowest. We can use this to estimate the standard deviation. So just range divided by 4. Remember, this keyword here is estimate. Everything you get here is not accurate. It's just approximation. So it only works when you are lazy or your boss is not very detail oriented. So if we know the standard deviation, we can also go back to estimate the range. Once we get the range, we can estimate what is the highest value, what is the lowest value, using such a formula. Again, I want to remind you, we are just approximating. This is not accurate. This is just, those formulas should be only used when you are lazy or the question specifically said or use this approximation. So let's continue. So use the range rule of sum to approximate the standard deviation for the dataset above. How was it? To the actual standard deviation calculated. Okay, so we need to compare with the actual standard deviation. So since we're not doing example 5, we can just use example 4 as an example. We're doing standard deviation for example 4. So let's just do it for example 4. What is the range? The highest value minus the lowest value, right? The highest value is this guy. The lowest value is this guy. So this guy minus this guy. You should have like 60. $69. So the range 102 minus 33 should give you 69. And the standard deviation should be the range divided by 4. Approximately, okay, approximately. So this guy divided 4, 6, 15, what is this guy? 69 divided by 4. So let me do a quick calculation. So you should have 17.25. So using this method, we have standard deviation approximately equal to 17.5. However, look at the standard deviation we really get. Standard deviation we really get is 25.77. So they have a very big difference. Okay, Just let it aware they have a very big difference. This is only approximation. Okay, so we reached the end of the class. So let me take the attendance. If you have any question, please stay here. Otherwise, feel free to go. Okay, bye guys.